Algebra 2 Engineering Problems, Solving Words Problems. In this video, we show you some of the words problem you can solve using quadratic equation within a range of Algebra 1. Let's look at the problem first. The height of falling object is h equals negative gt squared plus v0t plus h0, where g is gravity acceleration, which is about 9.8 meter per second square. v0 is initial speed, the speed when you start measuring the height. Okay, so initial speed, h0 is initial height, g is 9.8 meter per second square. I hope you learn the physics by the time you reach to the Algebra 2. Otherwise, you just have to learn this now. It's here. And initial speed is 4 meter, h0 is 0. Okay. How high will this object goes up? Calculate the maximum height. Okay, so the falling object, that's what it is saying is initial speed is 4 meter per second, but it's get deaccelerated by gravity and come back because acceleration is g acting opposite direction. Okay, that's my interpretation of this problem. So what's happened is the height equation is given by gt squared plus v0t plus h0, and h0 is 0, means you're measuring from here, ground, h0 is 0. So measuring from here, the height function by time is given already. So what you do is to find the maximum h, the height max. How high will it go, right? When this is 0, then v0 minus gt, right? And this will be like t and h, and the height is going to go up. When t is 0, it's 0, and come down. What is this value? This one 0, right? The roots. So t is v0 over g. Okay, here's I think some error. Usually it has a 1 over 2 in front. Correct equation. So it's going to be 2v0 over g. Okay, maximum height, it's right in the middle, right? So this is the time t2, t1 is 0. When you say the root of this is 0, and t1 is this value, right? And half of this is v0 over g. And when t is this value, height is maximum. So you plug in this to this equation, then h equals minus g, 2g, I'm sorry, and v0 g square plus v0 v0 g. Okay, and so it's going to be v0 square minus over g minus v0 square to g. It's gonna be half 2g v0 square. Okay, so this is gonna be the height. So this is how you calculate. This answer is wrong because 1 over 2 is missing in the physics equation. But you can use a quadratic equation formula if you like, or you can get from roots, right? T0, T1, 2 roots, and take the middle value. And that's the way you calculate minimum and maximum. If you remember the previous quadratic functions video, there are 2 ways. Take the midpoint of 2 roots. When you can find the 2 roots. The roots you can find that by factoring, or you use a quadratic equation. Quadratic equation gives you the maximum point. The answer is not quite correct for this one because it's forgot 1 over 2. So question is the 4 times 4 is 16 over 9.8 times 2. Okay. So next question. In nuclear fission, not fusion, right? Fission is the atoms break down. Each atomic reaction generates 3 neutrons. Each neutron causes a new atomic reaction. In this chain reaction, how long will it take to burn the entire nuclear material of 106 atoms? Assume time for each reaction is 2 microseconds. Now actually it's much faster, I think. The neutron flying speed is too fast, so we can ignore the flying time. So every 2 micron, three reactions happen, right? T is, say, 1 microsecond, the unit, microsecond unit. Every 2 microsecond, the 2t is the number of reaction after t microsecond. Sorry, over 2. Every 2 microsecond, it's called 3. So 3 times 3 times 3, number of times. So this is total number n. Okay. So n is 106. In order to reach 106, what is t? That's a question. So if you take log 3n, that's a t over 2. So t is 2 log 3n. So this much time is needed. So the question is, how long will it take? So t microsecond it takes, and n is 106. So hit the calculator, you get the microsecond it's needed. This is the practice of exponential function and the logarithmic function. Next. Grapes are kept in a dark room for fermentation to produce wine. Each year, 1/3 of chemical compounds break down by natural process. We need to wait until 98% is broken down. How many years will it take? Okay, so each year, the 1/3 breakdown, so 2/3 left. Next year, 2/3 of 2/3 left. Following year, 2/3 of 2/3 of 2/3 left. So remaining quantity n equals times number of years x, right? And the remaining quantity become 0.2%. Okay, so if you take a logarithm, x is log 2/3 and 2%, which is 0.02, right? So you hit the calculator to calculate this, how many years it's going to take. That's the answer. Okay. Find the condition for the satellite to be geostationary after launching. This is a very general question. Find the conditions. Well, after launching geostationary, that means this is Earth and satellite going around this, the angular speed omega is same as Earth. What is Earth's angular speed? It's 360 divided by 24 times 60 times 60. So this is the angular speed, degree per second. Okay, that's the speed Earth is rotating. This satellite going the same speed. In order to stay in orbit, the satellite has to have a balance between the gravity and acceleration. Acceleration is r omega square. Well, you have to go back to physics to get this formula. It could be, you can say v square over r, right? That's acceleration. The v is r omega, so that's acceleration. And the gravity is g, right? So r omega square equals g, and we know omega square, so condition is r is g over omega square, and omega is given here, right? So you know the distance, the orbit radius, to be the geostationary. Here's some calculation. The g, you have to use the accurate g. You cannot use 9.8. 9.8 meter per second square is on the surface of the Earth. When you talk about gravity at this satellite scale, then this distance changed to gravity. So you have to use this equation, right? So here the g is actually gm, gravity constant, and the Earth's weight over r square. So the r cube is going to be gm omega square. Okay, so it turned out to be about 173 kilometers above the Earth's surface. Okay, you should check it out, the other reference, see if this value is correct. The geostationary satellite is useful for communication because it's staying at the same position in the sky. So like a satellite TV, you set the antenna to the fixed angle. Satellite is always there above sky. Okay, I hope you enjoyed this video, and I'll see you next time.